the important limit is this. Limit as h goes to 0, a to the power of h plus 1 over h. If we have this limit, the answer to this limit, or the limit, is ln a, where a is the base of the exponential function. So, for example, if I want to find the limit of 2 to the power of h minus 1 over h as h goes to 0, of course, if I want to find this limit, I have to approach 0 numerically, because if I substituted h as 0, I will not be able to determine anything, because I will have a 0 in the denominator, which is something we cannot calculate. Of course, there is nothing to factor, so we can cancel out the h. There is no irrational or square root or anything to get to rationalize. So we have to approach 0 numerically by making each approach 0 from the left and the right. If you keep doing this, I'm not gonna spend a lot of time doing that, but if you keep doing this, you will find that you are approaching 0.691, which is the same thing as ln 2. If you want to try again with another base, so limit as h goes to 0, 5 to the power of h minus 1 over h, here the base is 5. You will find this, and you approach 0, as I said, numerically. You go close to 0 from left and right. You will find that this will approach, or will come close to 1.609, which is the same thing as ln 5. So this will help us when we use Newton quotient rule to find the derivative of e to the power of x. So what we want to put in our mind, that the limit of a to the power of h plus 1 between brackets divided by h will equal ln of a as a base. Okay, this is the first thing we want to learn now. The next thing is we need to find the limit. We need to find if f of x equal e to the power of x, find f prime of x. So Newton quotient rule says limit as h goes to 0, f of x plus h minus f of x. We know that all the derivative rules coming from this principle, Newton quotient rule. So if I want to do that, this is the limit as h goes to 0, e to the power of x plus h minus e to the power of x, this is f of x plus h, minus f of x, which is e to the power of x, divided by h. Again, now if I substitute it with h, it will not gonna work, because I will divide by 0, which is something all of us know that we cannot do. So we can rewrite this in this form: limit as h goes to 0, e to the power of x times e to the power of h minus e to the power of x over h. It is very clear now what we need to do. Yes, we need to factor e to the power of x out. And this will leave e to the power of h minus, don't forget, 1 over h. It is very clear that e to the power of x will not going to affect the calculation of the limit. So I can take this out of the limit and find the limit of whatever remains inside. I will try to save a space, so I will rewrite this here: e to the power of x, limit as h goes to 0, e to the power of h minus 1 over h. So this is the same thing as e to the power of x ln the base, which is e. ln e. What is ln e? How we calculate ln e? ln e means, what is the base here? It is e. So we need to know e, which is the base, to the power of what will give us e. Of course, it is very clear that it will be 1. So this is the same thing as e to the power of x times 1, because when we have the number here and the thing here and the base the same, the result is 1. So we end up with this. So f prime of x, f prime, so I will write this in here, if f of x equal e to the power of x, f prime of x equal also e to the power of x. And this makes sense because in the first video when we were talking about what is significant or why e is important, we said that the slope of the tangent when x equals 0 at the y-intercept will equal 1, and we said that the slope of the tangent is f prime at that number. So in here, when x is 0, f prime of 0 will equal e to the power of 0, which is 1, and that makes what we said in the last video true. Okay, see how things are linked together? This is the thing I want to tell you, and this is the derivative of f of x equal e to the power of x. So the derivative of e to the power of x is the same function, e to the power of x. Okay? So this is the first rule. And it is driven from Newton quotient rule, as I told you, like any other derivative rules. It's the first principle of derivatives. Now we want to talk about what is a composite function. We said that, let's say we have f of x equal e to the power of x and g of x equal x squared plus 5x minus 2. And we have a new function called h of x, which is a composite function of these two functions, which is equal f of g of x. So as I told you before when we studied this in advanced functions, we said that we are going to start from inside out. So I will take g of x and put what it equals, x squared plus 5x minus 2. Then I will substitute this in the original function. So I need to find f of this. So that will be e. Instead of x, I will put whatever between the brackets. So this is the composite function h of x that is equal to f of g of x. And we said before, if we have h of x equal, I want to write this in a different color. If we have h of x equal f of g of x, to find the derivative, this equal f prime of g of x times g prime of x. This is chain rule. We learned that in the first unit. Chain rule. Okay? So, for example, let us say I have to erase this. So, chain rule is this. So, I don't know how many, 13 minutes. I hope that. So, let's say we have f of x equal e to the power of 3x squared minus 2x plus 1. This is a composite function. It is made of two functions. The first one is e to the power of x, and the second one is 3x squared minus 2x plus 1. This is the result of the composition, or the composition of these two functions. So to find this, I have to use chain rule, which is the derivative of e to the power of anything is the same. Remember, f of x equal e to the power of x. The derivative of that is e to the power of x. So now we're going to write this as it is. E to the power of 3x minus 2x plus 1. Are we done? No. We are not done. We have to find the derivative of g of x, which is 6x minus 2. So this is how we find the e to the power of g of x. We write e to the power of g of x as it is, and then we find the derivative of g of x. Another example, let's say I have f of x equal e to the power, let's use any quotient or anything, e to the power of 5x over x squared minus 1, something like that. So in here, f prime of x will be, I will write this as it is, e to the power of 5x over x squared minus 1 times the derivative of this, of the g of x, the exponent. I have to use quotient rule, which is low squared, low d high, minus high d low. Okay, and of course we can simplify this, but this is not the point for this right now. We need to apply the rule and we master it first, then we are going to do the simplification and the algebra work. I want to give you another example. What if I have a constant in front of the function, 3e to the power of x squared minus 2x, something like this. The 3 is constant, so we can leave it outside, and then we find the derivative of this, which will be e to the power of x squared minus 2x times the derivative of g of x, which is the exponent, 2x minus 2. Okay, now we have learned how to find the derivative, and then we can distribute the 3 over this thing. Now we have found the derivative rules. I want you to do some questions